Hey everyone, welcome back to the lab. In this video, we're going to be reading and reacting to Random Thoughts, 15 years into software engineering. I stumbled on this post this weekend and I really liked it. And so I kind of wanted to share this and offer some more context from my own experience working as a software engineer. Okay, so I'm coming up on 15 years of professional software engineering. It's quite a long time. So this guy's probably like a staff engineer or something at 15 years, maybe just a senior engineer who works a lot. I've worked at companies from unknown startups to large FANG like Silicon Valley companies and everywhere in between. In no particular order, just sharing some thoughts, some things I've learned that others may find helpful. Now, I really like when people kind of contextualize their experience. One, of course, it gives them some authority to what they're talking about. But two, I actually think, and I think I've talked about this before and probably will, again soon, is that different kinds of companies, whether they're like FANG-like or kind of mid-sized non-tech companies or tech startups, they all actually have different paradigms that are more effective in one of them, but may not translate well universally to other ones. An example is, I kind of use the metaphor like if you're working in big tech, you're kind of like a city planner. Like there's a whole department for electricity or water and sewage or building permits and all sorts of these things. So when you're on a team, you're really specialized in this one thing, but you're doing it at like planet scale, which means things are probably going to go a lot slower and you're going to have like a lot more internally built up infrastructure. Whereas on the startup side, it's going to be more like there's one team for an entire neighborhood or for an entire town or something like that. So you're much more generalized across different things that you need to build. And this just means that different values and lessons are going to work more for one or the other. So I like the contextualization here. Theoretically, these lessons are a little bit more universally accepted and useful than if you were just like one or the other or spent your career in one or the other. Okay, on to the lessons. First, try not to think in absolutes. Computers are great at binary, humans not so much. Every rule has an exception. Every architectural approach has a trade-off. Yeah, I think this is very true. There really is no one true thing, because often, like even if it is the true thing for like a given point in time, often things will just change. There's like three constants. It's like death, taxes, and change. And so I do think it's really important to not like be super tied to either one solution, or it could be like a technology or a rule or a system or a process, because often, though they might be the best right now, they might not be the best if one thing changes or you discover something. And what this also means for you as like a person is like oftentimes, software engineers get into these discussions about like Go's better than Python, Go's better than Rust, Rust's better than Python, whatever it is. To have those discussions, yes, but like don't like die on that hill because, it's probably not worth dying on. This is just a battle. It's not the end of the war. Okay, moving forward. All right, the next lesson is debuggability is highly underrated. When writing code, you have to think about how it will execute. You also need to be thinking about how it will fail and how you will debug it in production. Leave yourself audit trails, store data in human readable formats, and invest in admin tooling. Yeah, I would definitely agree with this, but I would maybe rename it a little bit. It's not that debuggability is highly underrated. I would probably say the more general rule is that the bottleneck in software is humans. The reason we build software, the reason we build all this tooling and stuff is for humans. And the most costly thing about running software is almost always the humans that are employed to build and change and debug, refactor, maintain, all of it. And so when we're optimizing code, like a lot of times on the internet and stuff, especially with benchmarks and stuff, they'll be like trying to do these weird optimizations to like get more performance out of the code. That's cool. That's fine. Love that for them. But in real life, in reality, in a business context, the impact is almost always more useful to focus on how do we make it more efficient for the human. So in this case, the author's talking about debuggability. Yeah, you should always leave, traces and have good logs. I love the idea of having little counters for function hits or having really good observability when errors happen and to like where it actually happened. There's a lot of ways you can do this at scale. So yes, debuggability is good. He's also talking about using human readable formats. So I'm a huge fan of JSON because if something's failing and you're sending it over the wire, assuming it's not super sensitive, so where you should like encrypt it or something, it's so much easier to be like, why is this failing? Look at the payload and be like, oh, it's sending me the right payload or the wrong payload. Whereas if you're doing all this like G-zipping stuff, you actually can't see it anymore. And so now there's an extra step to actually doing the debugging. Similarly, this is, I talk about this a lot, how I think static types are way better than dynamic types. And it's this because we're actually optimizing for the human, because we're getting these errors at build time to where we don't even have to go through all this faff of debugging things in prod that are are hard to reproduce because a type system, if it's a good type system, can usually catch all this stuff for. So I totally think this is true, but I would probably say again that you need to optimize for the human bottleneck, not just, the perf bottleneck. Projects are late a lot. This is not unique to software. The reality is that time is constantly moving against us, and when unexpected things happen, they can take an order of magnitude longer than we plan. And in software, there's always more we can add to a given feature or system. Give a best effort and keep your stakeholders informed of progress and blockers. Yeah, I think this is true. Basically, everything is more complicated than you assume. And the best thing you can do is your best effort, but that should never be like working too much. Like you should never be giving like 60, 70-hour weeks because I guarantee those last 30 hours are like not that useful because you're tired and you're angry and you're irritated and you're not actually thinking of like good solutions anymore. You're just code monkeying, and code monkey code is monkey code. So would never recommend that. And so I do think the best thing to do is just give yourself good plans, cut down on the scope, as I think he talks about later in this post, and really focus on prioritization because there's just a lot of unknowns in software and the world and the business cases. Things are changing all the time. So it's just going to happen. So I do think managing this is optimal for everyone involved, even though nobody likes a late project. Often that is better than lying or cutting corners or getting the thing wrong. Okay, aggressively manage scope. Related to the above, protect your project scope defensively, as people will often try to add things throughout the project. You don't have to push back if you don't want, but be transparent about how it will affect the project delivery and communicate it widely. Defensively, look for things you can cut, or my favorite, look for things that you can ship after launch and push to prioritize those at the end. I love a good fast follow. So I think this is true, but this is going to be hard, I think, for people who don't have a lot of experience to figure out what is important to keep in scope and what is important to keep out of scope. And so the better piece of advice that I usually like to give is to really focus on impact. So your job as a software engineer is not just to code and implement. That is part of your job, but it's not the only job. If that was your only job, you'd basically just be like a code monkey translating from one thing to another. But direct translation is never actually what you want. You got to translate the intent, right? You got to translate what is the person actually trying to do. Let me give you the best way to actually do that, not just go word for word. And so if you focus on impact, like what is the person actually trying to accomplish, then it's much easier to figure out how to organize the scope such that you accomplish those things without all the extra baggage that is likely in this thing that they're giving you. So an example is like they want this feature and they want it fully translated and they want like these new UI elements. Like really the most important thing there is likely the feature. And then you can say, okay, the translations are important because we're in all these different countries, but probably some languages are more important than others. So that's how you can cut that scope. You can think about like the UI changes, like, hey, they probably don't know that some of these UI changes might take a few months. And so you kind of got to escalate that. It's like, are you sure these are important? Usually they're not. And so then you can say, kind of cut that out of scope because it's not actually blocking the main impact, which is that feature. And then these fast follows are a really great way to say like, hey, we will get to the other languages. We will get to these UI things later. And what you'll find is as you start prioritizing this way, a lot of things get pushed off and they actually end up not being important, or they're nowhere near as important as the other things. And so this is a good way to get real impact out faster. And by focusing on impact, you can much more easily understand what part of the scope is useful and what part of the scope, usually a lot of it, is not that important. Okay, next. Staging is pretty much always broken. I see a lot of younger devs hand-wringing about testing environments. Don't get me wrong, testing environments are great and you should use them, but the larger your systems get, the harder and harder it is to maintain a parallel environment that actually mirrors production in a meaningful way. Make a best effort, but don't sweat it, and don't be afraid to test things in production safely. Feature flags are your friend. Yeah, I would go further and say that production is pretty much always broken. You know, I worked at Instagram for 3.5 years, and I was on a team that oversaw a lot of like the observability and logging for video, which is like a lot of the platform. And let me tell you, production was always broken, but in many ways it didn't really matter because the user experience wasn't hampered enough for most people to care. A lot of people say Instagram is very reliable, but from the inside, I'll tell you, it was always on fire. But that just goes to show how good our backups were for showing like not meaningfully degrading the experience when the systems were broken. And I think actually that I would go so far as to say that staging and testing environments are often a code smell and actually mean they're not good because I think they give you false security. Like you think because you have staging and it doesn't break in staging that it won't break prod. That's almost never true because this staging staging or testing environment, like he says here, is almost never the same as production. And so whenever you get these things where build is different than testing is different than production, you're gonna find cases where they didn't align, and so your assumptions aren't true, and therefore what you build is broken. And so the way that I like to build is very much like you have, yes, your local thing and your tests, and yes, you'll hopefully run some tests in your CI and stuff, but then you just go to prod. And so this forces you to realize that this code that you're writing, like, there is no safety net. Like, it is going to prod, so you need to build your own safety net. So things like feature flags, things like observability, making it very easy to debug later on. Things like, how do I, what exceptions will this throw? What tests do I need? This is stuff you need to be thinking about and you should be thinking about. And so the more that you believe that you're pushing directly to prod, and that you will need to test in prod or, deal with reality at some point, I think the better the code gets throughout the whole CI process. Okay, next is action is rewarded. Pointing out problems or complaining is not. So sure, yeah, just pointing out problems or just complaining is not super rewarded, but I would say that this is very valuable. Like, the whole idea that you see something and you say something, that is a necessary part of the improvement loop, because if nobody starts it by pointing out that there's a problem, then it can never be prioritized by saying like, oh, 10 people have this problem and then actually fixed. So this is very important. This is not a way, you should not do this. But I agree that just doing this is not like that useful as a software engineer. Like, you need to also be fixing things. However, I don't like this idea that action is rewarded. That's actually not true. What's rewarded is outcomes. Okay, so impact is rewarded. That's why I like to say focus on impact. The impact of what you do is important, but you just working a lot, like again, 60, 70, 80 hours a week, you're working a lot, you're doing a lot of actions, that is meaningless. Nobody cares how much you worked. Nobody cares how many actions you took if those actions are useless, right? Like, you just going through all the docs in Confluence or whatever your wiki is and like updating the punctuation so that it's like follows whatever the latest English thing, like, that's so much work and totally useless. Nobody cares. So what I would say is focus on impact, and then those who are producing impact is very important. So like, instead of going through all the wiki pages and updating all the punctuation, if you wrote one wiki page that makes it clear how to do this one thing that everyone struggles with, that is so much more impactful and probably only took you 20 minutes versus like, your 80-hour week of fixing the punctuation. So true, but focus on impact, I think, is probably a better lesson here. Take ownership of your systems, not just your code. Act like you are personally responsible for the success of the systems you work on end to end, because yeah, this is true. And there's probably a larger lesson here, and I'll probably do another video or post on like the top 3 lessons I would give, but I think this is true. So you should definitely take ownership of your systems. But I would go further into say, take ownership of your business area, right? So again, as a software engineer, if you want to get better as a software engineer, like, you can't just do what people tell you, or else you're a code monkey, and that's actually not that valuable. Like, eventually I think AI will also be good enough to do decent coding. That's actually not where your value is. Your value is in translating from the business needs, the why we're doing things, into real things that could be implemented well and actually getting that impact. And so I guess what I would say here is really understand and own your business system. So everything from understanding why your business needs to do what it needs to do, what are people trying to accomplish, and figuring out what are good systems to build that actually solve for those goals. That whole ownership is going to get you way farther than just like, here's this one little backend server that I'm going to build, because you can build a backend server in unlimited ways, but only a few of them are impact for the purpose that it's actually there. And so you must understand, why does that server exist? What is it trying to solve, to know how that thing needs to evolve, if that makes sense. And I think this is probably connected to this one. So you are part of a larger organization. The software you produce might be the product it sells to make money, but that doesn't mean your job is the center of the universe. Take time to meet people from other functions, sales, marketing, finance, etc., and learn how they think and work. You have a much more holistic view of the entire business, and decisions that come down around you will make a lot more sense. This is true even in the smallest of startups. So I do think this is true, and it goes back to like the focus on impact and understand why you're doing things. But I think, again, it has this little fallacy in it that says the software you produce might be the product it it sells to make money. This is never true, okay? Like you must, like it's never the software actually that's important. It's what it allows you to do that is what's being sold, right? So like, let's use Buffer that allows you to, schedule things to share. What is this offering? This is actually offering ease of use to creators to reshare their stuff on different socials for less time and less mental overhead, and they can plan ahead, right? That's what you're selling. You're not selling a website. No, what you're selling is the ability for that person to do their thing easier. And if you think about it in this way, that really what the business cares about is like the thing that the value it's producing to make money, your software is going to be so much better because you're not just thinking about how do I make this like the best website ever. Nobody cares about the best website ever. What they care about is it's the best thing at doing the job it was hired to do. So both of these are true, but it really needs to go further than just your service or your piece of software into what is that software trying to accomplish in the grand scheme of the business ecosystem, your customer to the business to what this software is supposed to do for them. Okay, ask dumb questions. If you're in a group of people and have a question about what is being discussed, there's a great chance that someone else in the group has the same question. Speak up. Ask that question for the good of the team. Nobody will remember that you asked a question, but you and everyone else will forever have the information and the answer. Yeah, I think this is true. I think people should ask more questions. And I'm a big fan of like, if you are not totally clear on something or you just want to make sure that an assumption has been thought about, definitely just ask a question. In the worst case, it's like a dumb question and so they have a one-word answer. That's great. It didn't take a long time. But you'll be surprised how many things seem foundational and obvious, even just like core premises of things that haven't been spelled out, that when you ask them, you actually realize that everyone's on a different page and nobody actually understood the thing that was being proposed because a core premise was wrong. So I definitely recommend doing this. The way I like to do it is to kind of think of it as like a depth check. Like if things seem mostly fine, then just ask one or two core foundational questions just to make sure that the person thought about it. Whether it's a risk or like, how are you going to do this? Whatever. I think this is really, really important for gaining alignment. And also as you get more senior for setting direction, because as you get more senior, you can't do everything. Like you can't work more really. You can only prioritize better, and asking good questions that really force the other person to think about whether this will work or not is a great way to set them on the right path without expending too much time for you. So definitely getting better at asking questions I think is really important in your career. Okay, you won't have time to go back and fix technical debt. Don't kid yourself. Do your best to minimize it up front and prioritize what to address based on what you would be okay living with for the foreseeable future. 99 out of 100 times you won't get to come back and fix it until this particular part of the system needs a major overhaul and you don't know when that will be. Okay, so this is true. Like I said, everything's always broken. Staging, prod, everything's always broken, okay? Technical debt included. Does it matter? Yes, sometimes. So this again is almost kind of feels like that, oh, you get rewarded for action, but that's not true, right? What you get rewarded is for the impact. And so things are always gonna be broken. And as you build things, you're gonna learn more and realize that what you did in the past wasn't optimal because you're learning more. That's just okay. Like if you spent your time perfecting something, probably both, it's a waste of time, and your perfect is no longer going to be perfect in like a few weeks when you learn more about the domain. And so it's just a total waste. I'm a big fan of like the, done is better than perfect. Don't let perfect be the enemy of good, everything like that. It just needs to be an iteration. And so, yes, I think you should do your best to minimize it up front, but only within reason. And then you just need to be okay with the fact that things are gonna change. And so whatever you built will probably break in some way in the future, or won't be optimal. And so just focus on, making it easy for the human. You're optimizing for the human bottleneck to make it easy to change and debug and stuff like that. But also just be okay with the fact that there's going to be tech debt everywhere. And the best way to deal with it is to just kind of fix things as you go and notice it, and probably avoid these major overhauls, avoid just these huge refactors just to fix tech debt for no reason. Because in the end, there's probably only 1 out of 100 problems that are actually meaningful to the business. And that's what you should focus on is tech debt. Everything else is just whatever. Okay, enjoy it. If you're anything like me, working with code is fun. Sometimes I still laugh that someone is willing to pay me a significant salary to do something I enjoy so much. Yeah, I'm a big fan of this. I also love coding, obviously, so I like solving these problems. It's fun, etc. But previously, like earlier in my career, I definitely was very like ambitious and trying to like be as efficient and effective as possible. And I don't think it was healthy for anyone. Like, you don't ever want to work with the jerk on your team, but but you also need to make sure that you're not the jerk that everyone doesn't want to work with, right? It's just not fun, and actually I think leads to worse effectiveness overall, even though you feel like short term it's being more effective. So I would probably change this, like, yes, you should enjoy it, but really just be positive is probably what I would say. It's going to lead to better outcomes for you, for your team, for your org, which then pays dividends back to you overall. So that's definitely what I focus on. Anyway, I read this weekend, thought it was a great read. So hopefully you found some of these tips useful, some of the added context useful, and I'll probably be doing a post soon on kind of like my top tips from my own career, what I think I would give to any other engineer trying to improve. So thanks for watching. I'll see you in the next one.